Chapter 4. Mineral and Power Resources. Let's learn minerals, metallic and non-metallic minerals, distribution of minerals, power resources, conventional and non-conventional power resources, conservation of mineral and power resources. The Earth's crust is made up of hard rocks which in turn contain solid substances called minerals in various proportions. Minerals are formed when natural elements on the Earth go through weathering processes such as evaporation of water, extreme heat and pressure. Unlike minerals, rocks do not have a definite chemical composition. Minerals present in rocks give us various metals and useful chemicals. The amount of minerals present in a rock varies greatly. A rock containing a large proportion of certain mineral is called that mineral's ore. Minerals are naturally occurring in organic solid substances and are found in Earth's crust mostly in the form of ores. They need to be extracted and purified before being put to various uses. Minerals have the following characteristics. They are exhaustible. Their distribution is uneven. They are created by natural processes. They have a definite chemical composition. They are mixed up with large amount of impurities. No country in the world is self-sufficient in all the minerals. Info-hive. The process of extracting refined mineral or metal from its ore is called metallurgy. The mineral resources of Earth have been exploited and used since prehistoric times, and various stages of human development have been named after minerals, such as the Stone Age. This age marked the time when early humans made their weapons and utilities from stones. The Copper Age. Copper was probably the first metal that humans learnt to mine, and with its use began the Copper Age. The Bronze Age. The era of Bronze Age started when humans developed a stronger and more durable metal by mixing copper with tin. The Iron Age. Bronze Age was replaced by Iron Age about 3,000 years ago. The Steel Age. Now in the modern times, Iron Age has been replaced by the Steel Age. Types of minerals. Minerals can be classified on the basis of their physical properties such as color, density and hardness, and chemical properties such as solubility. On the basis of composition, minerals are classified into two main categories, that is metallic and non-metallic minerals. Info-hive. At present, more than 3,000 minerals are known to humans. Here, look at this table. Minerals are divided into metallic and non-metallic. Metallic minerals are again divided into ferrous minerals and non-ferrous minerals. Metallic minerals. Minerals which contain metals in raw forms are called metallic minerals. Metals are strong, ductile, good conductors of heat and electricity, opaque to visible light and reflective after polishing. Most of the metallic minerals are found in igneous and metamorphic rocks. Metallic minerals are mostly found in nature as ores. Metals in their pure forms are obtained after separating them from ores. The process of separating metals from their ores by the use of heat is called smelting. Metallic minerals are further classified into ferrous and non-ferrous minerals. Ferrous minerals. Minerals which contain iron are called ferrous minerals. Example: iron ore, manganese, pyrite, chromite, nickel and cobalt. Non-ferrous minerals. Minerals which do not contain iron are called non-ferrous minerals. Example: bauxite, tin, copper, gold, magnesium, etc. Non-metallic minerals. Minerals which do not contain metals are called non-metallic minerals. They are generally bad conductors of heat and electricity. Limestone, nitrate, sulfate, mica, potash, coal, salt and gypsum are examples of non-metallic minerals. Non-metallic minerals are generally found in layers of sedimentary rocks. Coal and petroleum are used as sources of power or fuel, hence they are also called mineral fuels. Some minerals like tin, gold and diamond are also found in alluvial deposits. InfoHive. Archaeologists have unearthed copper pipes through mining from as far back as 3500 BCE that are still in good condition. Mineral extraction. Generally, minerals are located deep inside the earth, but some of them can be found at or near the earth's surface. Minerals can be extracted by the following processes. First, mining. The process of taking out minerals buried under the rocks is called mining. The following are the methods used for mineral extraction depending upon the depth at which the mineral occurs. Open cast mining. When minerals are taken out by removing the surface layer, minerals are recovered from open pits and hence the process is called open cast or open pit mining. Minerals which lie at shallow depths are extracted by this process. Here is the picture of open cast mine in Khetri, Rajasthan. Shaft mining. When deep bores called shafts are made to reach the mineral deposits at great depth, the process is called shaft mining. A shaft mine has numerous underground pathways and chambers. Drilling. When deep wells are bored to take out the mineral, the process is called drilling. Petroleum and natural gas are extracted by this method. Quarrying. When minerals are located very close to the surface and are simply dug out from near the surface, the process is called quarrying. Granite and limestone are extracted by this method. Distribution of minerals. Metallic minerals are usually found in igneous and metamorphic rock formations that form large plateaus. Non-metallic minerals are usually found in sedimentary rock formations of plains and young fold mountains. The Earth's surface has a highly uneven distribution of minerals. As mineral extraction is a very expensive process, only rich and adequate mineral deposits are worth mining. Brain tickler. Why are minerals unevenly distributed around the globe? Asia. Rich iron ore deposits are found in China, Russia, Southeast Asia, Azerbaijan, and India. Asia produces more than half of the world's tin. China, Malaysia, and Indonesia are among the leading producers of tin in the world. China is also a leading producer of lead, antimony, and tungsten. Deposits of manganese, silver, gold, nickel, zinc and copper are also found in Asia. India is the largest producer of mica in the world. India and Indonesia are the leading producers of bauxite. Europe. The availability of minerals in Europe was a major cause of industrial revolution. Europe is the leading producer of iron ore. Russia, Ukraine, Sweden, Spain, Germany, UK and France have large deposits of iron ore. Deposits of copper, manganese and nickel are found in Eastern Europe and European Russia. Rich deposits of lead and zinc are found in Belgium, France, Spain, Poland and Germany. Bauxite is mined in Norway, UK, France, Austria, Italy, Russia and Germany. Africa. Africa is the largest producer of diamond, gold, cobalt, chromium and platinum. A large portion of world's gold is produced in South Africa, Zimbabwe and Zaire. The copper belt of Africa runs from Democratic Republic of the Congo to Zambia. Guyana is the leading producer of bauxite. The Democratic Republic of the Congo is the largest producer of cobalt, while uranium deposits are mostly found in South Africa and Niger. Ghana and Gabon have rich deposits of manganese. Oil is found in Nigeria, Libya, and Angola. North America. There are 3 regions in North America which have mineral deposits and they are as follows: the Canadian Shield, iron ore, nickel, gold, uranium and copper; the Appalachian region, coal; mountain ranges of the west, copper, lead, zinc, gold and silver. Iron ore is found around the Great Lakes. The largest deposits of lead and zinc are found in British Columbia, Canada. Mexico is the largest producer of silver in the world. South America. The Eastern Highlands, regions in the Andes Mountains, and Venezuela have rich mineral wealth. Brazil is the largest producer of high-grade iron ore. Chile and Peru are leading producers of copper. Brazil and Bolivia are among the leading producers of tin. Deposits of gold, silver, zinc, chromium, manganese, bauxite, mica, platinum, asbestos, and diamond are also found in South America. Mineral oil is found in Venezuela, Argentina, Chile, Peru, and Colombia. Chile is the main producer of nitrates. Brain tickler: can we recycle minerals? Australia. Australia is the largest producer of bauxite. It is among the leading producers of gold, diamond, iron ore, tin and nickel. Copper, lead, zinc, tin, uranium, silver and manganese are also found in Australia. Large deposits of gold are present in Kalgoorlie and Coolgardie areas of Western Australia. Antarctica. Geologists have estimated deposits of a variety of minerals in Antarctica. Forecasts have been made about significant coal, copper, uranium, gold and silver deposits in the Trans-Antarctic Mountains. Iron ore is estimated to be present near the Prince Charles Mountains of East Antarctica. Distribution of minerals in India. The distribution of mineral resources in India is highly uneven. The northern plains of India hardly have any mineral resources, while the Chota Nagpur Plateau and its surrounding areas possess one of the largest concentrations of mineral deposits in the world. The distribution of important metallic and non-metallic minerals in India is provided in the table on the next page. Info Hive. The Kolar gold mines are among the deepest in the world. Power resources. Coal, petroleum and natural gas are the main sources of power. Their demand has been increasing with the economic development in the world. Power plays an important role in industrialization. It is needed to operate big machines. Economic growth is closely related to availability of power. Energy is required to perform various activities in every field. However, the distribution of various power sources is highly uneven. Table showing distribution of metallic and non-metallic minerals in India. Metallic minerals. Location: iron ore, Jharkhand, Chhattisgarh, Odisha, Madhya Pradesh, Goa, Maharashtra, Telangana, Bihar, Andhra Pradesh, Tamil Nadu and Karnataka. Bauxite: Bihar, Karnataka, Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, Gujarat, Maharashtra and Tamil Nadu. Manganese: Jharkhand, Bihar, Rajasthan, Maharashtra, Madhya Pradesh, Chhattisgarh, Odisha, Karnataka and Telangana. Copper ore: Rajasthan, Madhya Pradesh, Jharkhand and Chhattisgarh. Gold: Andhra Pradesh, Tamil Nadu and Kolar in Karnataka. Non-metallic minerals. Location: mica, Jharkhand, Bihar, Andhra Pradesh and Rajasthan. Limestone: Andhra Pradesh, Maharashtra, Jharkhand, Odisha, Madhya Pradesh, Chhattisgarh, Rajasthan, Gujarat and Uttar Pradesh. Salt: coast of Gujarat, Maharashtra, Andhra Pradesh, Tamil Nadu, Rajasthan, Sambhar Lake. Gypsum: Rajasthan, Jodhpur, Bikaner and Jaisalmer districts, Uttar Pradesh, Himachal Pradesh, Gujarat, Jammu and Kashmir, Tamil Nadu. Diamond: Madhya Pradesh, Panna, Telangana, Golconda. Conventional and non-conventional are two types of power resources. Coal, petroleum, nuclear energy and natural gas are conventional power resources. They have limited reserves and are likely to be exhausted. On the other hand, solar, wind, geothermal, tidal and biogas energy are non-conventional sources of energy. They have unlimited reserves. Let us read about these resources in some detail. Conventional resources. Conventional resources have been in common use for a long time. Coal, oil and natural gas are of organic origin. They are known as fossil fuels. They are also the non-renewable sources of power. Coal. Coal has been a major industrial fuel since Industrial Revolution of 1688. It is the most abundant fossil fuel which occurs in layers of varying thickness in sedimentary rocks. The four varieties of coal are peat, lignite, bituminous and anthracite. Coal is used as a domestic fuel and also in industries. Most of the thermal power plants use coal as a fuel. Coal was formed from giant ferns and swamps which got buried under the earth millions of years ago. Hence, coal is also called the buried sunshine. China, USA, Germany, Russia, Ukraine, South Africa and France are leading producers of coal. The coal reserves of India are estimated at about 1,60,000 million metric tons. About 98% of these deposits belong to the Gondwana age of the geological past. The block of the Indian coal deposits is of inferior quality. About 4/5 of the coal belt is confined to the Damodar basin. The well-known coal fields in the area are Raniganj, Dhanbad, Giridih, Bokaro and Jharia. The other coal fields are found in the valleys of Godavari, Wardha, Son Mahanadi basin and in the regions of Satpura, Chhattisgarh and Devghar. Coal is also found near Darjeeling in West Bengal and in Mukum and Lakhimpur areas of Assam. Thermal power plants, cement industry and steel industry are the major consumers of coal in India. Although coal is widely available and is highly efficient in terms of electricity generation, yet it is very bulky to transport and it creates a lot of pollution. Petroleum. Petroleum is found between the layers of sedimentary rocks. It is extracted by drilling deep bore wells. The distribution of petroleum is highly uneven and it is mainly located along the young fold mountains, coastal areas and offshore regions. Iran, Iraq, Saudi Arabia, Kuwait, United Arab Emirates, UAE, Bahrain and Qatar are major petroleum producers. USA, Russia, Venezuela, China, Indonesia, Liberia, Egypt, Libya and Myanmar are other petroleum-producing countries. In India, oil fields are present in Digboi, Assam, Bombay High and Krishna Godavari Delta. However, India's total petroleum production is far less than its needs. InfoHive. Petroleum is used to make over 6,000 products. Petroleum is referred to as black gold because it is black in color in the crude form, and its derivatives are as valuable as petroleum itself. Today, its use is almost inevitable in our day-to-day life. A variety of products like kerosene, diesel, petrol, wax, plastics, lubricants, etc. are produced from this mineral resource. It is very easy to transport and it also forms the backbone of the petrochemical industry. Natural gas. Natural gas is found along with petroleum deposits and gets released when crude oil is brought to the surface. It is not easily available. Very few countries have sufficient natural gas reserves of their own. It is a cleaner fuel and is used as domestic as well as industrial fuel. The US has the world's largest reserves of natural gas and is also its biggest consumer. Russia, Norway, UK and Netherlands are the leading producers of natural gas. In India, natural gas is found in Jaisalmer, Krishna Godavari Delta, Tripura and in some areas in offshore Mumbai. It is fast becoming an important source of energy in India. Natural gas is easy to transport and can be transported through pipelines. It is much cleaner and cheaper than oil. Tidal power. The energy in moving water can be tapped to produce electricity. Electricity generated in this way is called hydroelectricity or tidal power. For harnessing tidal energy, rainwater or river water is stored in dams. After that, water is allowed to fall from heights. The force of the falling water moves the blades of the turbine. The rotational movement in turbine produces electricity, and the water coming out of the turbines can be used for irrigation. 1/4 of the world's electricity is produced by tidal power. Here is the figure showing you the world electricity generation by fuels IEA 2014 survey. It shows coal-generated electricity at 40%, natural gas-generated electricity at 23%, hydroelectricity at 16%, nuclear-generated electricity at 11%, and oil and others at 5% each. Paraguay, Norway, Brazil, and China are leading producers of tidal power. In India, Bhakra Nangal, Hirakud, Gandhi Sagar, Nagarjuna Sagar, Kosi, Koyna, Rihand, and Damodar Valley are important tidal power projects. Tidal power is non-polluting and cheaper than thermal power. Tidal power projects also promote fisheries and irrigation, but it is highly costly to set up a tidal power project. Vast areas of low-lying land are submerged due to construction of dams. It leads to large-scale displacement of people. Nuclear energy. Nuclear power involves harnessing the heat of radioactive materials to produce steam, which in turn is used for power generation. It involves the use of sustained nuclear fission to generate heat and electricity. Nuclear power plants provide about 11% of world's energy and 13 to 14% of the world's electricity. The first nuclear power station to generate electricity on a commercial basis was started in UK in 1956. USA, France, and Japan together now generate 50% of the nuclear electricity in the world. More and more developing countries are now opting for nuclear power as an alternative to conventional methods of electricity generation. India, Pakistan, Iran, North Korea, Egypt, Brazil, South Korea, Taiwan, and Argentina are a few of those countries. In India, Tarapur, Kalpakkam, Rawatbhata, Narora, and Kakrapara are the main nuclear power generating stations. About half of the world still uses firewood, charcoal, cow dung, and crop residue as domestic fuel. Hydroelectricity and nuclear power can help to bridge the gap between the demand and supply of power. Non-conventional sources. Sources of energy which are fairly new in usage are called non-conventional energy resources. Scientists are trying to develop non-conventional sources of energy for certain objectives. We need newer energy sources to reduce our dependency on fossil fuels. Moreover, we also need environment-friendly and pollution-free sources of energy which are renewable and could be easily supplied to rural, urban, and remote areas. Thus, it is called the energy of the future. Solar energy. Sun is the source of all energy on Earth. Solar energy can be tapped in different ways. Photovoltaic cells are used to convert solar energy into electrical energy. A large array of solar panels is installed in open spaces to produce electricity on a large scale. Solar panels are also used for providing power to traffic lights and street lights. Solar cooker is a simple device which traps the heat from the sun to cook food. A solar cooker can be made by using plane mirrors or spherical mirrors. Solar energy is non-polluting and non-exhaustible, but at present it is costly. It cannot be harnessed in all areas. Moreover, these are not very useful in the regions experiencing cold winters or high rainfall. Wind energy. Wind is another important source of non-conventional energy. Windmills have been in use since ages. They were used for running flour mills or sawmills during medieval times. Nowadays, windmills are being used to generate electricity. Here is the picture of the windmill farm. The rotor of the windmill is attached to a turbine which produces electricity. A large cluster of windmills for electricity generation is called a wind farm. Coastal areas and mountain passes are ideal location to set up wind farms as strong and steady winds blow there. The Netherlands, Germany, Denmark, UK, USA and Spain are leading producers of wind energy. In India, Tamil Nadu is the leading producer of wind energy. Although wind energy is non-polluting and is renewable, initial cost of setting up, repair and maintenance of windmills is very high. Tidal energy. Tidal energy can be harnessed by building dams at narrow openings of the sea. The movement of water during a high tide helps in turning the turbine which produces electricity. Russia, UK and France are harnessing tidal energy on a large scale. In India, tidal mill farms are present in the Gulf of Kutch. InfoHive. The Indian subcontinent has a well-developed surface transportation network inherited in part from the British colonial investments. Tidal energy is non-polluting and renewable. Its drawback is that it can be harnessed at selected locations only, and tidal energy plants have the potential to damage the coastal ecosystem. Geothermal energy. The heat energy from inside the earth is called geothermal energy. This energy comes out through cracks at some places. Hot springs are formed because of geothermal energy. USA is the leading producer of geothermal power. New Zealand, Iceland, Philippines and Central America are the other places where geothermal energy is being harnessed on large scale. In India, geothermal plants are present in Manikaran, Himachal Pradesh and Puga Valley in Ladakh. Geothermal energy is a very clean and non-exhaustible source of energy, but it can be harnessed at selected locations only. Biogas. Organic wastes, especially human and animal wastes, cow dung, dead plants and kitchen wastes are converted into gaseous fuel called biogas. It is ideal for villages. Farmers can install biogas plants which are also known as gobar gas plants. Bacteria decompose the farm waste in the biogas plant and biogas is produced in the process. Biogas is a very good fuel. It can be used as kitchen fuel and also for lighting. Organic manure, which is a byproduct, is highly beneficial for farmers. It is a low-cost source of energy, renewable and has the potential to solve energy need in rural areas. However, biogas is a greenhouse gas. It can lead to global warming. India is the leading nation in development and use of this technology. Conservation of mineral and power resources. It takes thousands of years for the formation of minerals and power resources, but we are using minerals and power resources at a much faster rate, and it may lead to their exhaustion. Hence, it is necessary to conserve them. This can be done by adopting the following steps: efficient utilization of resources, reducing the wastage during mining, employing better techniques for extraction and purification. Metals can be recycled many times, which can help in reducing the demand for fresh minerals, saving mines from collapsing, using more and more alternative energy resources. Only when these measures are implemented, we can ensure conservation of mineral and energy resources for a better economy and healthier environment in the future. Recap. Minerals have been an important source for the progress of human civilization. Minerals have definite characteristics, and on that basis we have metallic and non-metallic minerals. Open cast, shaft drilling, quarrying are the ways of mining through which minerals are extracted from the earth. Minerals are distributed unevenly all over the world. There are two types of energy resources: conventional, coal, petroleum, natural gas, hydropower and nuclear energy, and non-conventional, solar energy, wind energy, geothermal energy, tidal energy and biogas.